master's degree in physiology, biomechanics, and human nutrition. I've spent the past 2 decades competing in some of the most masochistic events on the planet, from SealFit Kokoro, Spartan Agoji, and the world's toughest mudder, to 13 Ironman triathlons, brutal bow hunts, adventure races, spearfishing, plant foraging, freediving, bodybuilding, and beyond. I combine this intense time in the trenches with a blend of ancestral wisdom and modern science. Search the globe for the world's top experts in performance, fat loss, recovery, gut, hormones, brain, beauty, and brawn to deliver you this podcast. Everything you need to know to live an adventurous, joyful, and fulfilling life. My name is Ben Greenfield. Enjoy the ride.
Hey neighbor, I always like to talk like Mr. Rogers when I'm about to ask you to go on an imaginative adventure. But I want you to actually go on an imagination adventure with me. Imagine if somehow you had this all-encompassing platform that allowed you to keep track of your blood and your stool and your saliva and your urine testing and all these different tests people are getting these days, along with all your self-quantified data from wearables like, the Oura Ring or the Whoop wristband or an Apple Watch or anything else that you might wear to track your heart rate or your heart rate variability or your temperature, or your sleep, or anything else. And then that same platform could pull in all the health testing that you've done in the past and just kind of make that part of the dashboard too, so you could have your whole health history in there. And then we're going to keep imagining imagine that the platform could basically use really, really good artificial intelligence, like highly advanced artificial intelligence, to tell you exactly how to eat, what the meal should be, protein, carb, fat ratios, what foods to select, what foods not to select, how to supplement, how to exercise, and much more, all from one single dashboard. And you could get all the testing done from the comfort of your own home without needing to drive to an expensive lab for multiple blood draws or fill out confusing paperwork. Well, that is exactly what this brand new company, Onegevity Health, is putting together. They've been working on this behind the scenes for years. I've known about it for a while, but I had to wait to do a podcast with these scientists before or until really this thing was actually ready, and they're now rolling out this whole dashboard and these tests and everything. So I figured it was high time I sat down with the 2 chief scientists for Onegevity to learn how this works, because I'm pretty dang stoked. I've already started my own testing with them. I've already got access to their dashboard. I've got like 6 gigabytes of data from my gut alone right now, but I can see exactly which supplements, which foods, everything. They use totally different sequencing, totally different technology than anybody I've ever talked to on this podcast in the past. And the guys I interviewed in today's show, which was recorded pretty much right at the Thorne research facilities in New York City, because Thorne basically owns and runs Onegevity. The guests are Dr. Joel Dudley and Dr. Chris Mason. These are cool cats. They're smart as hell. Dr. Dudley is the professor of genetics and genomic sciences at Mount Sinai, where he's also on the chair of biomedical data science and the founder of something called Next Generation Healthcare. He was director of informatics at something called NuMedii. He was a consulting professor at Stanford. He's been published in over 120 different peer-reviewed publications. You'll see this dude all over the Wall Street Journal, Scientific American, CNBC. He was named one of the 100 most creative people in business by Fast Company magazine. Smart cat. And in addition to that, he also has a Ph.D. From Stanford University School of Medicine. And then Dr. Christopher Mason is on the podcast along with Dr. Joel Dudley. And Dr. Christopher Mason is also a professor. He's a professor at Weill Cornell Medicine. and he's the director of something called the WorldQuant Initiative for Quantitative Prediction, which bridges prediction methods in finance with genomics. He has a deep history in artificial intelligence. He's spoken at TEDMed. Popular Science listed him as one of the top 10 most brilliant people in the world, which is kind of an honor. And he also has over 140 different peer-reviewed publications. He's been in Science, he's been in Nature, he's been in Cell, got his Ph.D. in genetics from Yale, and then also got his post-doctoral training in clinical genetics at Yale. And he is wicked smart, along with Joel Dudley. So we're going to unpack this whole blood, saliva, urine, stool testing piece. Hey, before we jump into today's show, just a few quick things. This podcast today is brought to you by Kion, Kion. That's my company where I source and design amazing supplements for you. And in our wide range of beneficial compounds that I've personally handpicked for you, you will find many products made by the company Thorne, including their multivitamin that I use every day, their creatine, one of the most proven sports performance enhancing aids, and just supplements in general. Creatine staves off things like sarcopenia with age, and it's a known nootropic. I mean, creatine flies under the radar, it seems, for aside from strength and power, but it's for so many things so beneficial. We've got their probiotic on there, their vitamin D, vitamin K liquid, just some of the best Thorne supplements are all over at Kion, because I have toured their facilities and will vouch for everything they do. They are considered to be one of the top clean, guilt-free supplement manufacturers on the face of the planet. So that's called Thorne, and we have all the Thorne products marked down at a discount over at Kion. So you go to getkion.com and you can get fantastic prices on all the Thorne stuff, along with all of your favorite Kion supplements. So in addition, this podcast is also brought to you by Organified Gold. It's like curling up with a nice piping hot cup of medicinal liquid, which sounds like it would taste like ass, but it actually tastes pretty good. They put turmeric and black pepper into this, along with a bunch of insulin stabilizing herbs and spices. They've got turkey tail, lemon balm, reishi. They put ginger in there. And when you blend this up, like I like to blend it up in the evening with a little bit of almond milk or coconut milk, and I top it with some cinnamon and some coconut flakes, and then sip it while I stare longingly into the fire, wearing my cowboy hat and smoking a cigar, naked. No, I'm just kidding. I don't do all that other stuff. But I do drink Organifi Gold and their new flavor, because I'm a chocolate fiend. Their new flavor, Organifi Gold chocolate, oh my gosh, it's amazing to die for. So anyways, you get 20% off all of the fine fare from our friends at Organifi. You just go to Organifi.com, that's Organifi with an I.com, and use discount code Greenfield. That's easy enough to remember. So Organifi.com and use discount code Greenfield. All right, folks. Well, welcome to the show. Chris, Joel are sitting here with me. You've just heard about these guys' extensive bios, and I'm actually holding this oddly shaped object that I believe is designed to collect my stool. It looks like a cross between a rocket ship and a dildo, and apparently this is the wave of the future. This is where personalized genomic testing, especially for the biome, is going, and you guys are at the forefront of this new thing called Onegevity, which I've already learned is not pronounced Onegevity. It's Onegevity. So tell me, what is Onegevity? Well, and when you begin to talk, you can introduce who you are, so folks can start to keep you straight as we go.
Sure.
I can also make one of you talk in a falsetto tone. If that's handy.
Auto-tune would be good.
Okay. All right.
Like T-Pain. So this is Joel Dudley here. So this is Onegevity, in short, is a health intelligence company that is really trying to bring the cutting edge science of precision medicine or precision health to the consumer realm.
Yeah, and hi, this is Chris Mason. So it really is, I think, a manifestation of a dream I've had for a while to bring the best and most sort of actionable information we have in the laboratory and give it to everybody and anybody who wants it. So this includes everything. We're starting with gut health in our gut bio product, actually, so people can get a complete portrait of what's inside them and basically have actionable insights from that, including what you should take, what you should eat, essentially things you can learn about your gut health. But then to expand out to everything about your genetic code, your DNA, also looking at what's in your blood. So it really will be integrated across every layer of your biology and make it so you can live a healthier, happier life.
Okay. Well, how did this actually come to be? Like where did Onegevity actually come from? I mean, you guys have a pretty extensive background in everything from artificial intelligence to genomics. So I'm curious how this actually materialized.
Yeah, so Chris and I do research for the last decade or so at top-tier medical institutions, working again in sort of personalized medicine space. And I think for me, it came from a frustration about how long it takes for that science to reach not only the clinic, but the consumer. So it takes 15 to 17 years for a scientific innovation to reach the clinic alone, and then many years after that for that to reach the consumer. So is born out of the frustration of how long that takes and how we're just barely scratching the surface of this technology in treating disease, and we're very far off in the sort of typical academic realm and using this technology to focus on health and wellness and health prevention. So there's pretty much no interest in health prevention in sort of mainstream medical research.
Now, I want to start to clear up a lot of the confusion around actual testing.
Yeah.
Because it seems like biome testing is a dime a dozen these days.
Yep.
I've interviewed folks from Viome before. People are aware of the American Gut Project, of uBiome. I mean, it's very, very simple to get the impression that you're simply going to poop in a tube and send it off and get results back that give you some clues as to the bacterial profile of your gut. How is this any different than anything else that exists out there right now?
Yeah, so there's actually a really big difference between what we do at Onegevity and what you'll get from other places. So in particular, almost all the work in the field and in literature in the past really 15 years has been done with an older technology, which is called 16S, whereas we do what's called shotgun sequencing, which is, as kind of the name implies, you fragment and shotgun and destroy all the DNA from your sample and look at the provenance or the source of where all that DNA came from. So it could be bacteria and viruses, which you've heard about before, and people have probably maybe even ordered tests before that might be listening. But we expand out to what are the fungal species that are present, or even plant, or even the amount of human DNA that's left over that we see in your stool itself as an indicator of health and sort of what's happening inside of you. And so we use better technology, better algorithms. The AI platform is built on all those studies that we've been publishing in the past 10 years that have understood where each molecule comes from each species. And so the technology is better, the algorithms are better, and most importantly, it's not just a PDF that you get. You just go, okay, I've got this profile. I might as well use it as like wallpaper in my bathroom. That's not going to help you, right? You might. You mean
like the PDF that says here's all the bacteria,
which is like, okay, that's interesting, but it's like getting a recipe in a different language that you don't know what to do with. In this case, we translate the language of the molecules inside your body and give you things that you can actually take, including products actually for probiotics, prebiotics, supplements that you can take into your body that will beneficially impact what's in your microbiome and maintain health or improve it. And then also actionable insights of what else you should be eating or taking or doing.
I think that's a key distinction from the companies that are out there, because obviously there are a lot of, as you mentioned, a lot of companies in this space already. I would call most of those companies recreational health information companies, not really health management companies, right? Because they're providing you health information that is largely recreational because it's hard to act on it, and they're not providing you a solution.
I don't know. I mean, like when I get tested, I've been tested by companies before, and I get the PDF that lists the percentage of all the bacteria, but then it says things like, here's the foods that you should eat and the foods that you should stay away from.
True, but they don't deliver those foods to you, and they don't provide that solution to you, and they don't actually give you the means to test and see if those solutions are actually, if you're responding to those on an individual level, right? So it's sort of a shopping list, and then that shopping list can change. But the key thing here is we're vertically integrated with Thorn, right? So we're integrating testing with the ability to design the interventions.
Thorn, who develops the actual solutions, like here is the actual supplement that could address this bacterial insufficiency or excess,
and directly basically give you something tailored just for you that's based on goods and supplements and probiotics, prebiotics, all manufactured here in the U.S. That we you can go tour the facility and see it's the best in class production for really. Anything you could buy at shelves, you'll see it. Mayo Clinic sells it to people at their hospital. You'll see it at shelves at Walgreens. You'll see it at supermarkets. You'll see, like, these are the best, basically, products that you can buy as an intervention for what we measure inside you, and then we can see, is it working? Are you part of the 10 or 20% of people who only have to take some of the probiotics once and they stick and they've been colonized and you're good, or some of them have to be taken continually by people, but we can measure that, quantify it, and then advise you.
Well, I definitely want to talk about that, about if you take probiotics, if it even has an impact on these measurements, because I question whether or not it does. But before that, you mentioned the type of sequencing you guys are doing. You said it was called 16. The one you guys are doing is shotgun.
Yeah, 16 is like considered a swear word in my laboratory. If you say it, sometimes people will tackle you.
What's 16? Or 16S?
16S is a fragment of what's called the ribosomal RNA, and so it separates out what you could say eukaryotes, or sort of more like animals and plants, versus what are called prokaryotes or archaea, are these microbes. They're literally a different sort of kingdom or domain of life, and so the 16S, the original, that sort of fragment of a gene, was how this new class of bacteria called archaea were first discovered by Carl Wolf. So, basically in the 70s, there was really an excitement in microbiology because we just used that method to find a whole dramatically different domain of life, which lived in hydrothermal vents or really extreme places. So it has utility in research, and it's been around for decades, but it was never designed as a way to profile an entire ecosystem, like in your gut or in a field of soil in a prairie. It is just a way to count a general view of what's there and a way to discover something dramatically different, like at a kingdom level. But what we want to do is find things down at the species and strain level that are the most important for your health and obviously even disease. Like, for example, E. coli, almost everyone that's listening has E. coli in them or in someone next to them, but you're not sick from E. coli. When you hear about E. coli in the news, you think, oh no, there's an outbreak of E. coli on lettuce. It's a very specific strain of E. coli. It's not just E. coli.
And other strains can be beneficial.
Beneficial, right? So, and 16S gives you almost none of that resolution, whereas we get all of that resolution.
16S would just say you have E. coli.
It would just say, not even that, it would just give you the genus or maybe even the family. It'd say you have something in, Escherichia. It wouldn't even say E. coli. It would just say something at the genus level. It'd be like saying, are you Homo sapiens? You could be like, well, I don't know, I'm kind of a primate and I want to do a clinical trial on some primate and then, make recommendations on that. You'd want to do a clinical trial on an actual human being, not just a random primate or something that has a core date like a spine. That's a bit too vague.
I think we're almost starting over in microbiome research. So even though there's tons of microbiome research, there's decades, and there's all kinds of interesting associations with everything from depression to cardiovascular disease and metabolic health. A lot of that, again, has been based on 16S sequencing, which is this low resolution. So we're now sort of almost starting again from scratch because shotgun metagenomics is getting to a point where we're going to have to go back and reprofile and really learn again what's happening in the microbiome with this much higher resolution technique.
What is metatranscriptome analysis? Because I see that word thrown around as something that companies are using.
So metagenome is all of the DNA, and meta just means across all species. So you're not just looking at just bacteria or only, say, human DNA or fungal. You're looking at all the DNA, metagenome, all the genomes, whereas metatranscriptome is everything that's made from DNA into RNA and the sort of that landscape as well. So it's all the RNA that you'll pull out of a sample. So it could be from skin, it could be from your gut, again, it could be from a prairie, and you just extract all the RNA out, which is when DNA gets transcribed to become a more active molecule, that is the transcriptome. All of the transcriptome of one species is called the transcriptome, and if it's all species, like human, fungal, bacteria, even viral RNAs, it's called the metatranscriptome.
Why wouldn't you just do that instead of shotgun sequencing?
So we've tested this. We actually have led studies with the FDA, with NIST, to look at basically international standards for metagenomics versus metatranscriptomics, and in the literature, the idea is that, well, if it's RNA, that means it's active, so maybe that tells you what's alive versus dead.
Right, that's what I'm thinking, is like the RNA would tell you what's actually going on.
But there's several challenges with the RNA. So most of the clinicians I know consider metatranscriptomics to be, quote, useless. They just don't even want to look at a data set if it's metatranscriptomics, because the RNA, while it's active, it's also then the most susceptible to degradation, and it even though the molecule is active, it is the one that is destroyed the fastest. Also, it's very you only get sort of the top few percent of the species that are active because they'll be the most they'll generate a lot of the RNA. So one cell usually has one or two or several copies of DNA, so you can quantify who's there a bit better than you can with metatranscriptomics. You'll just see who's the most active, but that doesn't necessarily tell you who might be present at a lower level that could be a higher risk. And so between those two things, and then also the databases are not as good, the methods are not as good for metatranscriptomics. It's a bit more new. And again, most of the people working in pathology or clinical labs have described it, in my experience, as useless because it's too noisy of a data and it degrades too fast.
Is shotgun sequencing more expensive?
No, they'd be about the same in price. I mean, in terms of once you get DNA or RNA and your goal is to sequence them, they could be relatively similar. But DNA sequencing was ways to make that cheaper, and what we're putting out is going to be cheaper.
And by virtue of the way that bacteria replicate themselves in their genome, which is different in some ways than humans, there are ways to infer activity from metagenomics, actually, of the bacteria. So just because you're doing metagenomics in DNA doesn't mean you're blind to that this sort of activity that you might capture with transcriptomics. There are actually computational techniques you can use looking at the metatranscriptomic data to sort of infer some activity of the genes from the DNA.
Mm-hmm. Okay, so right now what's going on is I would get a kit from Onegevity, and I would send off a stool sample. How large is this stool sample?
It fits in that.
Some of these tests, I mean, it's an ungodly amount, like a hot dog tray that you got to collect in your refrigerator for 3 days and send off in a prepaid FedEx bag. Like how much are we talking?
I mean, if you have a personal interest in storing a lot of your own material, you can still do that. But for our tests, you don't need
I do.
that.
I like it. I like to look at it.
There's a friend of mine. He
have friends over.
Yeah, just puts it in the freezer, labels it as meatloaf, and says, sees who finds it.
Halo top peanut butter cup.
So there's I should know a guy on Twitter though who's a microbiome researcher, and there is something called fecal microbiome transplants where to do it you can do an autologous transplant. You say if you get a gastrointestinal issue, you could actually transplant your own stool that you banked say years before as a way to treat yourself. And so even though there's a guy who posts this online, he says I'm putting it in my freezer. His wife, you have to make sure in a good marriage you communicate which stool you're putting in which freezer, of course. So I think, but he's doing it for a medical reason. If anything does go wrong, it gives you basically it's like a bone marrow transplant.
Yeah, no, I think it's a great idea. I was recently working on a chapter in my book about FMTs and Clostridium and longevity, and
C. diff,
it seems to make sense that if you're at a time in your life when your poo is healthy, why not bank it?
And that's actually one of the things.
Stem cells.
Yeah, exactly. So with Onegevity, one of the things we're calling almost like a virtual stool bank, where because we sequence deep enough and broadly enough, we can tell you what you look like when you're healthy, or people that have come to our company or customers that have come to us that have gut problems, we can address that. But even healthy people, it's really a snapshot of where you are when you're healthy that you can go back to if anything goes wrong. But without that profile, you can't get close to it, and you could even bank it as well. But the profile is the bare minimum of what you need to try and get back to where you were.
So it's essentially the amount of fecal matter you get off of one swipe with a toilet paper.
Small spoon, yeah.
Okay. Yeah. So then that goes off to your lab where it is shotgun sequenced, and then what happens?
And then so we take all those fragments of DNA, so we'll generate, at this point, about 6 gigabases of data, which is, millions and millions of fragments of DNA that we take each fragment and compare it to all known species, basically all 5 million known species to humanity. We check and see which one of them it came from. So at the end, then you'll get, once the mapping is complete, we then give you a quantification of every species. So bacteria, viruses, phages, so different kind of bacterial viruses, fungi, plant DNA. We even see the amount of human DNA. So we use this to get the first profile, and if we want, we could walk through what's in that report. You get a report that's linked. You can still get a downloadable PDF if you want to go back to the old school way of just staring at a PDF, but the site is interactive, and then importantly, it gives you suggestions on what you should order if you want to try and say to give an option for helping your IBS, or if you just want to sort of the other products that might maintain your health.
Are you measuring anything with the blood as well to kind of go along with the microbiome data?
Yeah, so that's the thing that will distinguish Onegevity really strongly going forward. Yeah. So is really the sort of multi-omics assessment. There's any one dimension is really limited in what it can tell you about your overall health, because what's happening in the gut, obviously, we might think is transferring into the blood, but unless we measure the blood directly.
Well, yeah, I mean, you get different data from different bodily fluids. I mean, a lot of people, they'll do, an organic amino acids test using urine, or like a Dutch test for hormones using urine, and then a complete blood count and comprehensive metabolic profile in the blood and the gut, and then like a genetic panel via the saliva. Yep. So you guys are pairing blood data with the gut data?
Yeah, so we don't know in the current product right now, but that's which was mentioned in our press release as part of the product roadmap. And for any, I think, health area that we look at, it's going to be a multi-omics, sort of assessment. And really, Chris and I's background on the academic side has really been around the
power.
How do you combine multi-omics data, for individuals, and then how do you do inference across all of those things, those dimensions simultaneously? So a lot of people will, say measure genome, measure blood, measure microbiome, and then they sort of look at those dimensions one by one and say, well, let's try to learn something from the microbiome, the blood, and genetics, but we have deep experience, and let's combine those into a single model, a single representation, so we can really understand what the interplay is between all these factors and what what it's telling us about what's happening in the gut and what's really driving the in the blood. And we use things like network modeling and things like that on the computational side. But that's really the key. No single dimension is really good enough to give you the full picture.
What do you mean network modeling?
So instead of just analyzing the genetics alone, or again, the microbes alone, you can actually build these network models where you can actually understand how are changes in the gut microbiome, for example, potentially propagating up to the blood. And what the network modeling will let you do is not just look at these sort of correlative associations, but really sort of help you try to untangle what's potentially causally, not causal is sort of a dirty word in biology, so you don't want to say causally, but is there a directional link between what's happening in the gut microbiome and what's happening in the blood, rather than just trying to guess from these correlations.
So what would be an example of things that you would measure in the blood?
Yeah, so to be determined, right? As we develop the products, and it's going to depend on the health condition, right? So what makes sense to measure in the blood, but bacterially derived metabolites, right? If we feel that there are some bacterially derived metabolites that might be being produced by the gut.
You mean the gut? The bacteria in the gut is producing certain metabolites that are winding up in the bloodstream, and you're measuring those,
right? Or you might assume, but maybe you don't know what the gut barrier could be disrupted, right? So, or you might think that they shouldn't be leaking into the blood, but you want to test to make sure, even though they're active in the colon, they shouldn't leak. But maybe there's a gut barrier issue, so we actually need to test in the blood.
And vitamin levels too. For example, vitamin B6, up to 85% of the vitamin B6 that's made in your body, it could be made by a species in your gut. So if you think, am I high or low in different vitamins, you might normally just look in blood. But you wouldn't be examining where the genesis of actually a lot of the vitamins are. I mean, basically, in our guts is a small pharmacy for all of us that it both makes and processes drugs and molecules and vitamins. And so in the absence of knowing what's in your gut, you could start to think about, I'll just do blood work and think about what I'm missing. But you can, create some new members of the molecular factory in your gut that can make them for you. And so part of the measurement is to see what do we predict is being made, both at vitamin levels, but also what are bacterial metabolites, which you can just predict based on who's there, the species. And again, it has to be the species and the strain level. You can't get it from, say I've just looked at, some broad class of bacteria, because you don't know what it is.
Which is why you need to use shotgun.
Right.
Okay.
Right.
Got it. Now I want to get back to the practical recommendations, and I'm intrigued by this idea of using artificial intelligence, and I want to learn more about how you're doing that as well. But I also know there's a lot of skepticism about this overall testing process as a whole, because you're using stool, right? Basically, whatever happens to be near the rectum and the anus when you test. How can that be reflective, or is that reflective of what's going on higher up in the tube? I mean, is there any evidence that really is showing what's really going on?
So the best models have been done in mouse, where it's much easier to get, say, 6 areas of the GI tract from even what's in the food to what comes all the way out at the end. And we have 2 additional studies ongoing to see,
because mice have 6 assholes.
Yeah, they've been. We all know that. Genetically
it's a scientific fact.
Interestingly, in grad school, I did make a worm that had 3 vulvas, which was a unique experience.
That's useful.
So it was a Lin35 mutation. It was just a small
multivulval species could be useful at some point.
And I went home at Christmas. My first year grad student. I'm going home at Christmas, and my grandma's like, "Oh, how was grad school? You're getting your Ph.D. That sounds exciting. And how's Yale? It sounds great." And I said, "Well, I made a worm that has 3 vulva." And she's like, "What's a vulva?" I was like, "Well, it's a reproductive organ, and the species is a hermaphrodite. So really, it can make its own babies. You put it on a plate, it makes its own progeny." And she's like, "Why are you doing this again?" And I just said, "Well, it's important in cancer signaling. It's really important." And I realized at that moment, looking down at the floor, like, I need a better way to explain this to my grandparents, right?
Well, in the biohacking sector, people are getting chlorophyll injected into their eyeballs or little magnetoreceptors in their ears, and I would imagine there's probably a few hackers doctors out there who would want an extra vulva.
It's it's a limited market, but I think they're passionate about it. Yeah, I think so.
Despite Chris's best efforts, that's not yet on the longevity product roadmap.
Right. So these mice, you're able to test them, and you're able to see the bacterial profile of different areas of the gut.
Right, and so it is very true that different areas of the gut. I mean, it's a digestive process, right? So your things are being broken down, decomposed. Ideally, we would love to get every part of everyone's esophagus, jejunum, duodenum, everything out to the colon. But the stool is we've from at least studies we've published, it's 70, 80, as much as 90% of the signal of what you're looking for, of what's actionable, is still in the stool. So I think there's other people who can. There's ways you can even swallow devices that would take sampling all the way through your GI tract, but I think it's not necessary, and it's also more risky to try and collect things higher up. But not to discount like Helicobacter pylori for driving ulcers. That's only more in the stomach, not at the end. So, but you can see most of what you'd want with the stool.
Yeah, I think this is where the machine learning part, or AI, however you want to say it, comes in. Is there have been very large studies published where they have done this sort of spatial microbiome sequencing along the GI tract, and publish these very large reference databases of, say, spatial microbiome.
That's what it's
sequencing.
Called, spatial microbiome. If you're going to take it from different areas, not just like one toilet paper swab.
Right. But because there's these big reference databases out there, what you can do with machine learning is take someone's sample from just one collection site, and then you could use machine learning to infer what are the likely upstream, depending on how reliable that signal is in that data, right? If there's a decay of signal, that's consistent. So this is really the power of using large published data sets that we've pulled into our platform, and this goes along with metabolomics as well. So there's been large reference databases published with where they've mentioned whole metabolomics on fecal samples, and they've done, say, metagenomics, and then we have a machine learning algorithm that can look at the metagenomics data and really build you a virtual metabolome using machine learning.
How much data have you pulled in? I mean, I don't know how much data there is out there on biome testing, but I was under the impression it was kind of a new thing.
But there's a lot of 16S data that's out there. For 16S, there's tens of thousands of samples, but for metagenomics that's paired with actual metabolomics, we've got over 2,000 samples, but that's the majority of the data that's ours plus public data. There's not that much that's out there. But you think, well, how can you do a classifier or machine learning on only a few thousand samples? The reason, and also there is a little bit of AI exhaustion, I think, in the field. People think like, oh, it's machine learning if you're writing code. It's AI if you're just talking in a nebulous way about doing something cool. But what we use is, the reason you can call it broadly AI is because you can use multiple kinds of machine learning on the data sets that we've curated. So this is random forest models, neural networks. Even in some cases, simple regression is good enough, but you can do multivariate regression. So you look at multiple variables at once. And what that means is you're not just, the reason we have all that information is because it's bacteria, viruses, it's human DNA, it's the mapping of each piece of DNA to every possible species. So in a feature space, it's actually very, very large and gives us many places to learn from. And that's why I think some of our excitement about machine learning and AI is built into the company is because it is to date by far the easiest and fastest and best way to take unstructured, sort of vague data of unknown importance and find signals in it and then actually act on them. And also separate out groups of high risk, low risk, IBS, IBD, healthy controls. It's actually shockingly easy if you have enough data.
Well, hello. I want to interrupt today's show to tell you about the best grocery store that exists that you don't even have to drive and park at because it's on the internet. It's this revolutionary online marketplace where you can get dark chocolate and coconut cereal and coconut manna and personal care products and household cleaning chemicals that don't give you man boobs or cancer, but that are actually handpicked to be extremely clean by the folks at Thrive Market. They have non-GMO food, safe and non-toxic beauty products, kitchen staples, organic baby food so you don't poison your baby, all sorts of amazing things, and it's fun to shop for because you can filter everything, whether you want to filter by ketogenic or paleo or gluten-free or vegan or even kosher. That's right, you can filter the cereal that you want to get by kosher. You can get paleo, kosher, granola. How do you like that? 70% of their catalog you can't even get on Amazon. Plus, their prices are rock bottom compared to like the fancy local, organic fancy pants grocery store. They're just wonderful. Even their packaging and their boxes and their inserts are made from recycled paper. 100% zero waste. These are all the goodies from our fine friends at Thrive Market. So here's the deal. If you go to thrivemarket.com/greenfield, you get 25% off your first order to Thrive Market. That's thrivemarket.com/greenfield. Have fun shopping because you get 25% off. Then may I recommend to you their coconut cereal. It's really good. Really good. Just saying. This podcast is also brought to you by PuraThrive. What's PuraThrive? It's actually kind of cool. They sent me some bottles of this stuff. It tastes really good. I just squirt it into my mouth, but I think it's designed to be maybe blended with coffee and stuff like that. But it's called Keto Balance. Keto Balance. So it tastes like a chocolate smoothie. It's like this liquid, but it's got DHA omega-3 fatty acids in it, grass-fed bovine collagen, and medium-chain triglycerides. They get their DHA from algae oil rather than fish oil, so technically it's like full-on vegan-friendly. They use this patented, well, no, it's not vegan-friendly. What am I saying? It's got bovine collagen in it. I'm sorry, my vegan friends, but regardless, I still think it's an amazing tasting supplement, and you should consider it either way. Like, it's just bovine collagen. That's all. The cows are all really, really very, very happy. So they use this patented liposomal delivery mechanism that increases the bioavailability of the compounds in there 20-fold. So you can get into ketosis faster, and you can avoid the keto flu, and you can achieve your keto goals in less time. Keto, in case I didn't say that enough just now. Anyways, like I mentioned, have used it. I use anything I mentioned on this show, and it tastes really good, and it does really, truly satiate your appetite. I just use like a little tablespoon of it. You're supposed to use a teaspoon, but I'm a glutton for punishment, and I think it tastes amazing. And I'm going to run out of bottles really soon based on the rate at which I'm going through it. So you get 15% off. You just go to purathrive.com/greenfield keto. There, I said it again, keto. purathrive.com/greenfield keto. That gets you 15% off. Again, purathrive.com/greenfield keto. So the AI is able to predict potential for certain diseases or conditions based on the shotgun sequencing of the stool sample that you send in, but then it's also able to generate targeted recommendations for the foods or the supplements that you should be consuming. Again, this is not based on metatranscriptome or 16S. It's all based on shotgun. That's right. So the list of recommendations you get from a test like this might be different than the list of recommendations that you get if you had tested elsewhere.
That's right. It would be different and better from our experience. And
this could potentially get very confusing for people who are sending their poop off to different companies.
Yeah, for sure.
But it should, I mean, this has happened also like with 23andMe or people doing direct-to-consumer just genetic testing. And then, I think once a year there's a New York Times reporter who says, well, I sent my saliva DNA to 3 companies and I got back different risk scores.
Exactly.
And
same thing with food allergies, right? I sent off my blood results for Alcat and Lisa, 3 different times and came back with different foods results to avoid.
And it depends. So, it's interesting. In that case, for people getting different risk for even, say, like diabetes risk, and they'll say, well, how did I get 3 different answers from 3 different companies? It would actually be a miracle if you got the exact same answer from 3 companies that all have 3 different databases that they're using as a reference. So it's interesting. I think there's a disconnect between the consumer view of what they should see. Look, when you think of your DNA, you look in the mirror every day, like, my DNA is mostly the same. I shouldn't get a different answer from 3 different companies. But each company has its own database, its own set of scientists, and actually literally different risk scores that they're calculating using different data. So Navigenics, 23andMe, some of the even Veritas, there's other companies where they'll give you a risk score, but it's actually not at all surprising that they're different. It would be, they should be broadly consistent, but they would never be identical because they're using different data. Where in this case, we too will be using different data, and we'll of course tell you that we think our data is more comprehensive and better. But in this case,
is it? Where's the data coming from on your end?
It's all public. So it's friends and family, early trials of our product. It's a clinical trial that we've run in the company, and every available public data set that we have that exists, basically. So it's I would even argue it's the totality of all public knowledge and all company knowledge on metagenomics and metabolomics.
Now, from a longitudinal standpoint, if people are doing this test, that database is going to continue to grow.
Right. And the machine learning will get stronger and better. It'll basically every day that passes, in some sense, the company and its ability to make better recommendations improves. And also, we're strong believers in if something doesn't work, if we've done something that's been hundreds of people, thousands of people, and we can quantify and literally do phenotype scores, and if no one's benefiting from something, we'll of course stop recommending. We'll stop, even stop selling. There's no reason to give some people things that don't work. It's unethical, frankly. And so even if you make money from it, our goal is not to profit, from just selling things. Our goal is to sort of profit in partnership with customers so that they're healthier.
Well, that's actually what I was going to ask you. Like, can pharmaceutical companies waltz in and buy this data in 10 years from now?
Now, they could propose a partnership, right? But it's on our terms, right? And as we mentioned in the press release, this has to be very transparent and shared and equitable to the consumers who are providing the data. So we're open to it because, to be frank, we still need lots of new therapies for lots of diseases, right? So look at Alzheimer's, for example, right? Alzheimer's is on the verge of bankrupting our economy, and we haven't had a single drug approved, right? So there's still work that needs to be done there, and we think this data we're collecting can be valuable for discovering new therapies, and so we do need to partner with those groups.
I actually thought that the cure for Alzheimer's had been discovered and involved putting MCT oil in your coffee and playing brain games on your cell phone.
Yeah,
I'm pretty sure that's how it works these days.
And I think some push-ups in the middle.
To a certain extent, push-ups and Wim Hof breathing. When it comes to what we can actually gather from the microbiome data, and this is going to kind of delve into some of these personalized recommendations that you're talking about, that this dashboard that you've created is able to produce. How does that actually work? How do you go from stool to shotgun to don't eat green beans?
So most of it's based on, as I was alluding to, a clinical trial, which we're just sending off for peer review just now. And so it's actually, the trial was extraordinary in terms of, we asked people to give a complete, sort of fill out a big survey.
You ran this trial internally?
Yeah.
To what population?
The mixture, mostly IBS and healthy control, IBS, IBD, and healthy controls.
Okay.
And it was a lot of quantified metrics of what are their gut issues. It was a 9-point measurement scale. We had an internal IRB and an external IRB. Review the study. Just completed it in December, and the results are really shocking because it was a relatively small trial, 96 people. But even just in that trial, we had almost perfect classification of people separating out IBD and IBS from healthy controls. We could tell, again, because we're looking not just at bacteria or just viruses, but across all domains of life to see what the separation is. And it was actually, literally some of the best data I've ever seen as a geneticist in my entire career. That in terms of a separation, it clearly show people that are at risk and people that are healthy. So that was already exciting. But then also, we did try different recommendations based on, and we did 2 time points as we think. I wish everyone was sampled dozens or hundreds of times, ideally on a minute-by-minute basis. But in this case, we only had 2 time points.
I poop a lot. You could probably test me a few hundred times a year.
We've got some interns that could follow you around. Yeah, I think this could be a good partnership. But we did 2 time points, which is the bare minimum to make a line. But it was to give a sense of what did we recommend at day 0, and then at day 30, what did the species that change, and also more importantly, what was the outcome? So I think you were alluding earlier, like people talk about probiotics and maybe they can help, or what should you take, what vitamins, what supplements, but are they working? And here we could quantify, was it actually helping at day 15 and day 30? And so that we should
you test these people and give them probiotic.
Yep, and also several
or a prebiotic, or it all depends. Depending what we found in their microbiome, you customize it. And the customization was driven by their microbiome. A lot of these other companies customize it based on the intake survey, and not actually on your microbiome data. So.
And you were able to use, because you guys are tied to Thorne, just the Thorne broad suite of the different prebiotic and probiotic formulations they have access to. You just kind of pick the ones off the shelf that seem to work best for that person.
Right.
So you're slapping those on these people with IBD and IBS and then retesting to see what happens.
Exactly.
And also looking at symptoms?
Yep. A 9-point scale for gut health, which includes things like how often did you have diarrhea? Some things are obvious. Did you have diarrhea, constipation? But other things, did you just in general feel gut pain, or did you have gas? Did you have any bloating? What are sort of some of the general sort of physiological responses you had in your gut? And actually, one of the best Christmas presents we had was getting some emails just from the customers who said things, that were really just like, that they've had gut issues for 5-6 years and have felt awful, and suddenly for the first time, in almost a decade, some of them, they feel great. And it was really extraordinary to see that, which gives us the inspiration to really push harder and faster, but also I think it piques the curiosity of like, well, why did some people have an extraordinary response and suddenly feel like they felt the best they have almost?
I'd be curious to see what happened if they just took some random probiotic, though.
Right. And so if they just take, or, because what we did here was a trial where we had 3 groups, healthy controls, sort of as a placebo, plus 2 other IBS, IBD, but what we're going to ramp up now is sort of a double-blind placebo trial.
I was going to say, placebo trial will be interesting on that.
And the healthy controls serve a little bit of that purpose, but doing it as double-blind is the next step, and also expanding the scope of it. So that's what we're launching probably towards the end of this month or next month. But I mean, the results, it was really extraordinary just to see, clearly some people are benefiting, extremely excited, but now we want to tease out at a molecular level what's driving that, what's pushing it in one direction.
I was going to say, that's my understanding, is we still don't know why. We still don't know what's going on. There's still some questionable science in terms of how much of that probiotic even survives the acidic nature of the stomach and winds up populating the GI tract.
Great point. So most of them do not only from working at our company, but also in our labs, but I'm on advisory boards for a variety of other companies in the microbiome space, and this is a universal feature. Everyone who's trying to look at, can we get something to get into your gut and colonize, it's actually really, really hard. I've seen numbers as low as 5 or 10%, as high as maybe 30% of people, where if you take something, it will actually stay in you. You're basically going to transplant a little species into an ecosystem that's already pretty settled. So it's not surprising, actually, that all these studies you've seen and read about probably say, probiotics, you have to keep taking them, which is great for a business model, but it's not great if you think I want to just take it.
It's not like your gut has these patches of soil that are waiting to be planted, right? So they have these other bacteria in various niches that they hold on to for dear life, and a lot of the molecules that that bacteria secrete are things to kill other bacteria to keep them off their turf, right? So this
Well, I mean, it's like a lot of things. Like I don't just drink 1 cup of coffee on a Monday and stay awake and alert the rest of the week. I have my coffee every day. You take your probiotic every day. Does Thorne actually make a special kind of probiotic that's supposed to seed the gut better? Because you hear about soil-based probiotics. I know there are companies now enveloping the probiotic in like algae or kelp or something like that to get it to seed the stomach.
So they do produce probiotics that have clinical evidence behind them, like S. boulardii, right, would be a good example where you can go to literature and you can actually see in IBD patients that there is positive outcomes.
Benefit,
But just because even though it doesn't graft into the microbiome, doesn't mean it's not providing benefits, right? So it could provide benefits because it's transiently secreting things as it's in there, or it creates a stimulation, but just by exposing itself to the immune system, that ultimately results in a beneficial thing.
That's how even helminthic therapy works.
Exactly.
The use of tapeworms or whipworms, which people do to modulate the strength of the immune system. I've done that, but you choose strains that actually don't populate the gut. They're transient passengers, but they still modulate an effect on the immune system.
So even if they don't graft, I think the important point is,
do they work?
They still might have an effect, right? Even transiently, that's useful. So we just have to know for who and when.
Right. You just have to get past the itchy asshole effect of swallowing tapeworms.
Which some people though want that. So it's a different customer base, and we're open to helping everyone.
It can be entertaining when you're bored to have to itch your asshole. So back to the food. So you've got the stool sample, you've done the shotgun sequencing, now you're generating the list of food recommendations. With these folks in this study, it sounds like you were using probiotic and prebiotic formulas. Did you also test out these food recommendations?
We sent the recommendations out, and we asked about compliance. So we did say, for example, gluten-free, dairy-free. We also, what's actually really exciting about the clinical trial, we just separated this out a couple of weeks ago looking at the data, because some people were already on gluten-free or dairy-free diets, and so we really wanted to separate out, well, if you were already on a diet, maybe you wouldn't have seen as much improvement, but if people who really, we made a recommendation of what they should eat or the type of diet, did that have an impact? And so we could see that specific recommendation with not only the foods but also the broad class of diet that had a significant improvement in their score. So a p-value of 0.0003, so it was very significant, and it's a small cohort, but we could see that it was different, and the majority of people improved.
And I think this is where Onegevity goes in the future, because again, remember, we're about not only the information but about the whole integrated experience and delivering the actual solution to the problem we find. So I think as we go forward, we're going to see ability to start delivering even some of the food products that we can verify.
Okay. When you're making the food recommendations, because I've toyed around with using data that I've gotten from other microbiome testing companies, there's a list of foods to eat and the list of foods to avoid, and that's what you get. When you're generating your list of food recommendations, are you saying Mediterranean diet, paleo diet, keto diet, food elimination diet, or is it just like eat these foods, avoid these ones? Like, how comprehensive are these dietary recommendations we're talking about?
Both those things, and also specific recipes. So one of the things is getting, ketogenic diets can be limiting in terms of ingredients, and so we've partnered with some chefs that can give very, nice actual meal options.
So on my dashboard, I can actually select what I'm going to have for breakfast, lunch, and dinner based on my microbiome results.
It's we have the recipes. I don't know if it's all broken down by meal yet, but that we could add in actually pretty easily. Yeah.
Can I get my food delivered to me if I don't want to make that myself?
So we have some ongoing discussions with a variety of few companies about this exact idea. And so that I think completes the circuit of everything from what we've measured in you, making sure we deliver.
Well, that would be pretty damn cool. And I realize there are a lot of people out there who are like, "Oh, you lazy bastard! You need to be making your meals in your kitchen."
They want to live healthy. I'd say they're efficient instead of lazy. You could say they want to get things done.
Well, you could choose your own adventure too, right? You could use the recipes that are generated for you by the artificial intelligence on the dashboard, or you could theoretically, and it sounds to me like you guys are building this in, just click and sign up for a meal delivery service.
Yeah, and it's not laziness. It's anything you can do to increase compliance, right? So if you actually go to the healthcare system and traditional healthcare, the biggest problem we have is getting people to comply with what they know they should do, right? So this is why you got to make it easy. That's how you're going to get the health outcomes.
And I mean, basically, then the food is basically genetically tailored for what's inside you. So it's and it's early days in this regard. So we've got promising results from our clinical trial and our early customers, but we want to actually really engage the customers. A lot of our literature and language on the website is really viewing all the customers as partners in this, improving how we do science and medicine and health.
And there's a lot that we don't know yet, that the world doesn't know yet about these relationships between food and microbiome, and this is something we're going to learn along the way. Getting back to the AI part of it, there's something in artificial intelligence called reinforcement learning, which is basically you try a prediction and you see if it fails or succeeds, and if it fails, you sort of boost, say, the neural network towards the thing that succeeded. The first demonstration of reinforcement learning that really captured everybody's imagination was they had I think it was Google, had an algorithm that looked at Super Mario Brothers. It just looked at the screen, and it would randomly press buttons on the controller, and it would see if Mario would go right, in advance, or the score would go up. They would reinforce the algorithm in that direction, right? It's saying, "Oh, I'm just randomly trying things. I'm reading, and this is reinforcing that this is the right direction." But this thing, by randomly pressing buttons and getting this sort of feedback, was able to play Super Mario Brothers at superhuman abilities without ever being told what the rules are or what the game is, right? So this is the type of thing you can learn with the longitudinal data aspect, with putting tools in the hands of our customers and partnering with them on the science. Is we're going to make recommendations. Some of them aren't going to be perfect, but the system is closed loop. It captures that feedback. We can apply reinforcement learning, and then for the next person, right, it's getting better and better and better.
And it quantifies it. I mean, the measurement is one of the key features, like the Super Mario Brothers. We want to be the Super Mario Brothers controller in your gut, I guess would be the analogy. Like
I think using the analogy of Call of Duty would probably be a little bit more palatable, potentially sexy, marketable to the general population.
So. There's tubes in Super Mario Brothers, I guess, but I think
that's true. That's true. It might be a little bit too old school.
Yeah, that's true.
Now, when it comes to the other type of recommendations that you make on this platform, you talked about using like the Thorn suite of supplements to say, hey, here's your microbiome, and it sounds like coming down the road, your blood results, here's the actual suite of supplements that you need to take. But where I see the world going when it comes to personalized nutrigenomics and customized supplementation would be that is actually customized to me, that supplement.
Yeah, exactly.
Or that probiotic strain or that prebiotic. Yeah. How close are we to that kind of technology?
Well, I don't think we can talk about it on the podcast, but let's say much closer than you think.
Should I edit this out? Or can you just say we're close?
Yeah.
We're
very close
on a variety of fronts. Very, very close. That that you could be, almost perfectly genetically tailored to what you would get.
Perfectly genetically tailored right now, though, on microbiome. How come you guys aren't doing saliva?
No, both. So when I say genetically tailored, I mean across all domains. So it'd be microbiome.
I would say actually molecularly tailored.
Molecularly tailored.
Yeah, because the blood will come into it as well.
So you're going to start with gut,
which is launched. Yeah.
Then you're going to do blood.
And genetics.
It was a partnership with Drawbridge Health, which, their device, the OneDraw device, is under FDA review right now for 510.
I don't know what that is.
Basically, is this an FDA-approved device? And so you can't really bring anything to the clinic, or you shouldn't bring anything to the market that's not gone through the FDA and approval. So it's in the middle of that process, and we expect it, soon. So I'd say spring, hopefully not later than summer. But then,
what are you talking about? The blood?
So that you
draw
you
device?
Basically, and it's basically something that fits in the mail. So you can just pop it under your shoulder. It draws blood, and it does it on a standard sort of collection. Instead of trying to do something like make an entirely new blood technology, it's just a way to collect the blood. Then we send it to standard labs.
You're sounding like that girl from Theranos.
That
didn't work out so well.
So I published the only academic paper evaluating Theranos against LabCorp, and I was on CNBC talking about it, if someone wants to Google. But I can guarantee you this is very different. So I contributed to the...
So you're saying I wouldn't have to drive to LabCorp or Quest Labs. Just come to the house. You put it on your arm. Yeah. It draws just a little bit of blood, then I send that off. And I could theoretically send that off along with my biome analysis.
Right.
And that blood will that blood do genetics as well?
Yes. You can get DNA and DNA.
Why wouldn't you do saliva?
So saliva, you can get an oral microbiome, and we're launching with saliva just because we can use that right now. But assuming we get as much DNA as we're seeing right now basically on the OneDraw device, you wouldn't have to do saliva anymore. You get everything from the blood draw, get DNA, and also sort of your metabolites.
Yeah, so we think it's going to be a game changer for the blood draw side of it. One, only because venipuncture scares a lot of people, just to even get a single blood draw measurement. But another powerful application is getting into this longitudinal analysis, right? So repeat blood draws become much more feasible over time, and to build out that dynamic longitudinal profile. And people can self-administer in the comfort of their home, potentially in the future. So again, that's all pending regulatory approval.
That's pretty cool. It's a lot of data you're going to be able to get, but it kind of reminds me of this article. I think it was just a few days ago. I was reading about how 23andMe either got bought out or infused with capital by a pharmaceutical company. Yeah, and that pharmaceutical company may then have access to the data.
Yep.
Mm-hmm. And what if I don't want my data public?
What are
you doing with the customer's data?
So by default, customers are opted out, and you can opt in if you want to share your data. And then also we've set it up so that we will basically silo what is customer data. And if there is a moment where we have a partnership with, say, a large pharmaceutical company or a biotech, we have committed to sharing any of the revenues that would come from that 50-50 with the customer. So we want to make it so that if anyone's using your data, which is your right to give away or do with as you please, if you've basically generously given it to the company for us to start to look at and learn from, you should also benefit if you then share that with anyone else. And so we want to make that as transparent and useful.
You mean I could make money off of my blood and my poop?
Your poop could be extremely valuable. I mean,
this could take donating sperm to the next level.
Yeah, that's right. You flush it away every day, but it could. For fecal microbiome transplants, it very much is sort of like a gold mine.
That's it. So what you're saying is, if I were to test with Onegevity, and 5-10 years from now, this data were to be something that I had opted in and was okay with being sold, I would actually profit from taking part in these tests.
Yeah.
Interesting.
Which builds a long view of the data and what we want to do with it. We want to really encourage people to be partners. And so the more measurements we get, whether it's blood, microbiome, metabolomics, the genome doesn't change that much, but all that information has value to learn and improve, not only for the customer but for everyone.
And there's a reason why we're able to do this, and it really gets back to our business model. Because again, a lot of these companies who are getting customers to subsidize the cost of the testing up front. And they're making their sole way of making money is through these data partnerships, right? So hoarding proprietary data is really central to their business model, right? Because they have no other way of making money. In fact, they might even be losing money on the upfront tests, hoping to make money on the back end. These recreational health information companies, because we are delivering products that people will only keep buying if they're actually fixing a health problem, when we make money on products. we have the freedom, in a way, it's not even the freedom, our business model enables us to be, open with the data and be able to share back with our customers.
That's interesting. Now there are companies like DNA Fit, for example, that are making recommendations on exercise. Are you a power responder versus an endurance responder? Should you be going high rep, low weight, high weight, low rep? Are you guys going to be working in any kind of exercise or lifestyle recommendations?
Yes, but sports and human performance will be a vertical.
How's that going to work?
Yeah, so again, it'll
be better because if you just look at the DNA, you can get a general recommendation. It's like saying if you sequence a baby at birth and say, how tall do I think this baby will be, or risk of disease, risk of cancer, breast cancer, you can put up numbers or what are sometimes called riskograms of what is the likelihood, and it's a broad guess. But I'm going
to be a bit more forward and say most recommendations based on DNA are bullshit because and so I wrote a book called Exploring Personal Genomics. It was one of the first books.
Exploring Personal Genomics.
Yeah.
Okay.
So when I was
I'll link to that in the show notes. By the way, just a quick reminder for you guys, if you forgot already, show notes are at bengreenfieldfitness.com/Onegevity. What's the name of that book, Joel?
Exploring Personal Genomics.
It's a book recommended to all the first-year medical students at Cornell as well. So it's when Joel's book came out, because we'd met a few years ago, I thought, this is actually a great book that summarizes kind of, if the textbook didn't exist, I would have wanted to write it, but it basically summarized everything you could know about, if you get your genome sequence, what could you do and learn?
So does it have lots of illustrations in it, very large words?
Lots of pictures. Yeah,
Good.
It comes with crayons too.
I'm in. Please continue.
So I'm not coming at this from someone who didn't participate in this. When I was a Ph.D. student at Stanford, I actually was lucky enough to be on the first paper. It was published in The Lancet of the first clinical assessment of a whole genome sequence that was used clinically. It was actually Steve Quake's genome. Steve Quake is a pioneer in gene sequencing technology and an entrepreneur. So this was way back in, I think, 2010. I think we did this study. So I've actually been in this business of clinical use of genomics for a long time. And so where the DNA is really useful is when you have something really wrong with you, right? So if you have a rare inherited genetic mutation like a delta F508 cystic fibrosis mutation, or any of these inborn errors of metabolism, or a hardcore cancer, somatic mutation. But when you have those DNA dysfunctions, you probably know before you get the sequence done, right? Because these are severe.
And they run the family often. There's heritability that's clear long before you.
That makes sense.
And it's really, I think the analogy though is sheet music, right? So DNA is just sheet music, and it is actually not totally useless in informing health, because otherwise we wouldn't be measuring it either. But it's sort of like the scaffolding that the dynamic measures of blood and microbiome and things need to be put on, because it is informative, but it can only explain a very small amount of your health outcome. And it is useful, but it's just sheet music, and people need to realize it doesn't tell you how the notes are being played in your body.
Got it. Okay. So eventually the exercise and the lifestyle recommendations will be rolled out, but they could potentially be more comprehensive because of the shotgun-based sequencing.
Well, and blood testing.
Yeah. And the blood testing that goes along with the gut. And correct me if I'm wrong here, but did you say you're already doing the saliva?
It's launching in probably 3 weeks. Yeah, so that basically you can then order a saliva kit and get your whole genome sequence as well.
Okay.
Today, what's launching on
your whole genome?
Yeah, whole
that's
genome.
Different than 23andMe.
So it's an important distinction there as well. Almost every other company out there does just a what's called a microarray, which means your genome is, say, it's 3 billion letters, 3.1 billion letters, and if you're looking in a book, what 23andMe does, or a lot of other companies, they only look at about 1 million of those letters out of the 3 billion, right? So you're really missing a lot of the information across what genome in terms of risk for disease, what you could optimize for performance, or even just traits. And so we do a whole genome sequencing to get as much information as possible.
So at this point then, I've got all this data coming in. You guys are going to be rolling out the exercise, the lifestyle, the diet, the food. You've already got some of the supplement recommendations, but they'll become more customized and tailored to me. What's this dashboard actually look like that I log into? Is there an app? Is it like a bunch of graphs? Like how does this actually work from a user interface standpoint?
Yeah, I'll jump in. So I think we wanted to make. A lot of the dashboards that exist are really clunky or non-informative, or sometimes too informative. So we wanted to make it as clear as possible. So on that dashboard, you'll see what are your levels of vitamins that we can measure, both it'll be in your blood as well as what we can as being produced by your gut. What are some of your general recommendations and risk for constipation, diarrhea, general inflammation? We give essentially what's driving some of the phenotypic scores that people have been reporting and that we can predict from the microbiome. And then again, we integrate what's present in the blood versus what's being, the sort of molecular potential of what's in your gut or in your genome. So you'll be able to see those. They are graphs, there's charts, but they're very clear and very simple. And every sort of chart has if you want more information, if you want to dive deep into this, so what are the dozens of papers that support this from the scientific literature, you can see that. If you want to go deeper into, how is vitamin B6 made and what else do we know about it and, what is folic acid, you can look at that and there's details.
And I think what the future roadmap has building in tools into this dashboard so people can start to run tests on themselves and trials on themselves, because ultimately
really
you shouldn't believe Onegevity or any company that's giving you this information, because again we're basing this on the best published literature, and it might come from New England Journal of Medicine from a huge trial, but it doesn't mean
it's good
in every case it's always going to work for you. We're going to bring the best science possible, but the whole point of Onegevity too is learning and filling in the gaps and things we don't know, and really bringing it down to the level of the individual. So on the product roadmap, we're going to start to build in the ability to do single N-of-1 trials, basically, right? So you get this information, and there's going to be a lot of things you could do, but you're going to want to be able to set your own goals, right? And say okay, well, of all these things, I want to, improve my sleep or whatever. And here's these things I could do. And I've got this recommendation for X product, whatever. I'm going to start to conduct a trial, right? And
see if it works.
So how we do it. So actually, on the academic side, I just published a paper on all the statistics, because doing a single trial on an individual prevents statistical challenges, right? But there's ways to do it. So I just published a paper with people on my team on N-of-1 trials and all the mathematics behind that. But we can actually wrap that into a very user-friendly experience where you say, hey, okay, this is what you want to optimize. This is the recommendation you want to take. Now we're going to guide you in a very user-friendly way for you to run this trial on yourself, and you can see the results and see if it's working. And if it doesn't, our database improves, and then we give you the next recommendation, and hopefully you can see for yourself that works.
And the importance is that everyone has a different baseline, both at a molecular level, what you're measuring for even just your baseline body temperature. We always think, that we have, you go to the doctor, you get sort of a standard blood panel, you have ranges, right? But if you think about it, that ranges in some metrics are very broad, but the power you get from longitudinal data is that your specific baseline for you, for your microbiome, for your metabolites, for the molecular features in you, once you know them after 2 or 3 time points, you can start to know that, this is what the baseline is. And so you look for deviations from that.
Here's a dirty secret in all of medical research is nobody knows what normal is or what it means, right? So every study you say, we can compare it against healthy normal controls. By the way, nobody has a freaking clue what that word means, how you quantify it. And it's usually, the definition is we exclude people who have the disease. We're interested in other diseases.
Lab reference ranges are always just one big giant parabolic curve.
So there was a paper in PNAS last year where they looked at these mental health outcomes that are often used in drug trials. And they did a longitudinal analysis, and I could pull up the exact paper. And we're actually submitting one from my lab that shows this is true in cardiovascular endpoints that are used. So basically, if you profile individuals longitudinally, and you look at the intra-individual variability of these measures, and the inter-individual between individuals, for some of these endpoints that are used in trials, the within individual, intra-individual variability is bigger. It has a bigger variance spread than the between subjects variability, right? So if anytime you look, so then that calls into question a lot of clinical trials, right?
Yeah.
Because the within individual variance is much higher. So this is why, as Chris mentioned, we need to do this longitudinal profiling, and we need to set individual baselines for that individual.
Yeah. Now, people know, if they've listened to this podcast, and I'm big into self-quantification. There's got to be 10 different lab tests that I do during the year from all 4 corners of the planet. So I'm juggling. I mean, you ought to see in my Dropbox folder, my lab results folder is just
That's great.
all over the place. Now, what I want and what I imagine is that I can get all of this done in just one place and have access to my entire dashboard and all the data in just one place.
Yep.
This kind of begs the question, though, what are you not doing? What are things that people might still, could you test Lyme or mold or mycotoxins? Can you do micronutrients? How deep can you go with this stuff?
really, I mean, we've gone really deep in other studies from my lab and Joel's lab. This is the core of the platform at launch is microbiome, blood, and sort of genome. But we can go very, very broad. So where we want to go next is further optimization of what we recommend for people, what they get, more the genetic tailoring, molecular tailoring of what you get. Mm-hmm. But there's lots of other things that we've published on that we know that can give you measures of health, wellness, and general even longevity. So this would be epigenetic age. How is your epigenome changing, which is sort of the small chemical features of your DNA and how it's regulated. So we've published extensive work on epigenetics and how that changes in normal people and also in cancer. So we want to see that as a metric. We can look at even the clonality of what sort of cells in your blood, which is called clonal hematopoiesis. It just means what proportions of cells are in your blood, and that can also indicate risk for disease, or even sort of blood age, if you will. And then I want to open it up to people basically to do everything that we've done before for astronauts. I think everyone should be able to be treated like an astronaut, and everyone should have the right to query any molecule inside.
I want to sure as hell be treated like an astronaut.
So we've done
hero, get a helmet.
Yeah, you should
be able to do the cool.
And you could have a bus take you to Kazakhstan. You should go up in the Soyuz.
Yes.
You should get some Russian.
I want
vodka.
this.
You can smuggle some things.
And I want a monkey to go to space with me.
We've got a monkey actually here in the office somewhere. We'll grab it. But it's just I guess just
not like a cheap hooker monkey, but like a real legit like Russian space monkey.
Really dignified, if you will. Yeah, dignified. So but we have a paper just coming out shortly. It's on the NASA twin study. So for those astronauts, we were sending one twin into space and his identical twin, Mark Kelly, staying on Earth for a year, and we want to measure them for 27 months. And one of the big questions of the study is, well, what changes when you're in space for a year, for that long of a mission? What should we look for? And because fundamentally we don't know in this sense, we've never sent a human into space for a year. NASA's never done that, so we didn't know what to expect. So we measured everything we could in this study, again, which is coming out shortly. It was genetics, epigenetics, looked at sort of proteomic changes or protein changes, looked at small metabolites, microbiome, looked at vasculature, looked at sort of cognitive speed and abilities. And that was really just to see what happens to the body in space. But we also pioneered new ways to do sequencing, in the space station. For the first time, we could sequence DNA in space, do diagnostic assays anywhere, literally in the space station. So the future, I think, is to do more of the omics, because you'll get more power that way, more time points, and to make it more personalized. So that if you want to do some of the sort of N-of-1 trials on yourself at home to test something and quantify it, see if it works, we want to empower that. If you even want to start to do some of the sort of metrics and measurements at home, we want to empower that, like with the OneDraw device, where you can draw blood anytime, anywhere, and ship it off.
What about data from like this ring that I'm wearing, like that does sleep, or Apple Health data?
Sure.
Like what about rolling that into the dashboard too, so you get more of the technical self-quant stuff like HRV, body temp, heart rate, et cetera?
So a huge amount of my research at Mount Sinai has been on wearables. Actually, I was part of the founding institutions that worked with Apple on the Research Kit platform when we've published studies, huge studies using Research Kit. So I have a huge amount of experience in that. That is definitely coming in, and we'll be pulling that information in. And I think
that is coming in.
For sure. That's in the product roadmap.
That's pretty cool.
So we're not a microbiome company. We're not a testing company. We're again a health intelligence company, right? So we're going to bring in whatever the best information, the best testing. So we're going to be on the lookout for different testing modalities, because we're not a testing company. We're a health intelligence and consumer health solutions company. So and even things like your own health records wouldn't be off the table in terms of things we could bring in. I have a huge amount of experience in my lab.
You mean importing my health records?
Yeah, from say Epic or something like that. So
that'd be very useful.
And the deep patient paper came out of Joel's lab, which is on sort of using a lot of machine learning for large scale analysis of electronic health record data. And it was the first paper that really had of that scale and of that kind of machine learning.
Theoretically, like a guy like me who is very into my health and optimizing longevity, I could waltz in and take that clunky Dropbox folder and just like have it all live in one spot.
And have it be browsable, have it trackable, and also make it useful. I mean, I think the biggest problem that we've seen in the field and a lot of other companies and even academic groups is you make a lot of pretty pictures, but there's nothing you can really do with them. So we want to be able to map if something's going in the right direction, the wrong direction, and give you things that you can order or that you can do testing on to improve it.
This is really damn cool. I wish you guys were doing all of this right now. But you are doing the gut and the saliva
pretty much right now.
Right now, yeah.
Okay. So the name of the gut test is Gut Bio. Gut Bio. Okay. By Onegevity.
Yes. Yeah.
So the way that people could do this is they could go to the website. It's Onegevity Health.com. So you could go to if you're listening right now, you could go to OnegevityHealth.com, and then if you click there, you could kind of browse around. Do you guys have any pictures or screenshots there of the dashboard and what it looks like? Just because I know some people want to visualize this.
Yep. So you can get examples. Okay. You can get a history of how we got involved and the research and our backgrounds.
Yeah, that'd be very cool just to be able to look at what you can't see on the podcast when it comes to kind of seeing what this dashboard looks like. So I'll link to this website, Onegevity Health, and then these guys have been kind enough to set everybody who's listening up with a discount on the test. So this test, to do this shotgun sequencing of your gut, is a $349 test. That's where you get the 6 gigabytes of gut data and the 38 trillion plus microorganisms in your gut. Just use code BEN20. That's BEN20 at OnegevityHealth.com, and that will save you $20 off of this test. So you use that. You get the kit to your house. What are the results? Like 2-3 weeks?
Yep.
Okay. And
so that's another differentiator too. A lot of companies, it's like 8 to 12 weeks to get results.
It's a long time.
It's just too long. I want things to be.
Everybody's always on holiday at the labs.
Yeah.
It's annoying.
So it shouldn't be. I mean, in the future, we'll just do it right at your house, and we'd have your customized Onegevity toilet that just pops up results every morning.
That'd be pretty cool, like a Japanese toilet that plays music and has the little
the heated seat.
The heated seat and the directed flow. Where if you aim it just right, man, it's a pretty cool experience. I'm just saying.
I've
spent a lot of time on those Japanese toilets playing around with those buttons, and I've gone some places that I can't talk about on the podcast today because there might be children listening.
That's right.
But regardless, you go to OnegevityHealth.com. The Gut Bio is the name of this test, and you use code BEN15. And as they roll out more tests, I'll keep you guys posted, because I plan on doing every single test that they do to start to build my own dashboard as I go along, because I do a lot of research into what companies actually have access to, the money, the labs, the technology, everything necessary to actually produce a lot of the things that we talked about on the show today: customized food delivery, eventual blood testing, eventual customized and personalized nutritional supplementation based on your data. These folks are actually positioned to do this at Onegevity, which I like. So you're probably going to hear possibly another podcast in the future as more tests get rolled out. But for now, this Gut Bio. But Onegevity is giving everybody who listens in a $20 discount on this test. So you knock $20 off the test when you go to OnegevityHealth.com, like ONEGevityHealth.com, OnegevityHealth.com, and that's where you can get this Gut Bio test, which is the first test that they're rolling out. So the code over there is BEN20 at OnegevityHealth.com. I am going to put all of this into the show notes, which again you can get at bengreenfieldfitness.com/Onegevity. And if you go to bengreenfieldfitness.com/Onegevity, you can also pipe in, leave your questions, leave your comments. I know some of this stuff can get kind of confusing in terms of, it seems like, everybody's testing the gut, et cetera, but hopefully we address some of those questions today. If you have more, though, go to the website, bengreenfieldfitness.com/Onegevity. Leave them there. And fellas, can I take this into the bathroom now and poop in it and
yes,
try this out? All right, cool. I'm going to go play around with this. And Chris, Joel, thanks for coming on the show, guys. Want more? Go to bengreenfieldfitness.com, where you can subscribe to my information-packed and entertaining newsletter, and click the link up on the right-hand side of that webpage that says Ben Recommends, where you'll see a full list of everything I've ever recommended to enhance your body and your brain. Finally, to get your hands on all of the unique supplement formulations that I personally develop, you can visit the website of my company, Kion, at getkion.com. That's getkion.com.